Hello, now if you see that here, next coordinate system is what? A spherical. So a spherical word came from where? A sphere. Okay. So you are much aware about this sphere. So what are the parameters are required to represent the sphere? Okay. So for that, here we have three variables, three parameters are r, theta, and phi. That we'll try to understand how we are getting here. Now, suppose for example, we are drawing one straight line here. So on this straight line, this angle will be how much? Suppose this angle is theta. So what is the range of theta here? Or if you consider that this situation like this, better we have situation where we are going to consider one small radius here, like length of this. Okay. So now, if this line you are going to rotate, okay, from this is the origin or center will keep, this line you are going to rotate here. So finally, this is going to form one semicircle. So on this semicircle, what will be the angle here? This angle will be maximum how much? 180 degree. Okay. And this one now you are going to rotate like a bow, you are going to rotate this one. So finally it will form the sphere. Okay. So that you are rotating here. So that rotation is going to give us the angle phi. Okay. So this we are going to rotate completely. So it's formed the like a latitudes. So that total angle will be here how much? 360 degree. Okay. So like this, we are able to get the values of theta and as well as phi. And radius can be 0, it can be the maximum infinity. On the basis of that, you will see the range. So first of all, we'll try to represent here again as usual. We are taking the reference of the Cartesian coordinates. This is x, this is the y, and this is the z. Now in this, we have to represent the one sphere. So for that, easily how we'll draw, so make one arc here. Now take some point on z-axis and join from there to here. Again, from that point, join on the x-axis. Now you take another point again here and join from there to here. So it look like you're keeping the pigeon in that case. That shape is going to look. So now another arc if you make here for the better understanding purpose. Okay. So finally, this is the our radius. On this we are surface, we are taking the point P. When we'll join that point P, that is going to give us the radius. We can have a better line. Okay. So this is our radius here. So this is going to make the angle theta with z-axis. And if we join this point here in the azimuthal plane, this angle is what? Phi. So this theta is going to change. What is the range of theta? Theta is going to change from the 0 to pi. Okay. 0 to pi. Whereas phi is going to change from 0 to 2 pi. And r is the radius. Okay. It can be the 0 or it can be maximum infinity. So like this, we are able to find the range here of the different three parameters. Same thing, now we are trying to find the relation of one parameters in terms of another parameters. That also we can find. Okay. How we can represent Cartesian coordinates in terms of spherical coordinates. That also we can write with the help of this diagram. Now here if you see that what like this is the if you globe is here, so this will call it what we are going to call this line, that is the latitudes. So that latitudes, what will be the radius of that latitudes? Okay, so this is our r here. So that latitudes radius will be what? R sine theta. R cos theta is coming along the z axis. Okay, so this radius will be r sine theta. So that is represented here, which is considered here as the rho. And along the z axis, r cos theta we have. So now this one, if you are going to project again in the azimuthal plane, that is xy plane. So again, we can find what is the x value, what is the y value in terms of rho and phi. Like this, we are able to convert one system into another system, and z value is what here? R cos theta. So now if you see the discussion part here about this differential, what is the value? Like we have differential length, differential area, and differential volume that we can find in this case. So what will be the differential length or differential displacement to so that you can observe this diagram. So if you'll observe here, one differential area is considered here. So for that differential area, if you try to find the different direction, different values here, so if you look for this arc, okay, so for that arc, what is the value? So if I'll try to represent here separately, so that can be drawn like this. So this value is what? This one is the d theta. Okay. And this one is what here? So it is moving in the clockwise as per the parallel to the azimuthal plane. Okay. We are rotating that latitudes. So that is not theta. That is what here? Phi. Okay. And this radius is what? R sine theta. That is our rho earlier. So finally, the length of this arc will be what? R sine theta d phi. Okay. Similarly, if you look for the another this length of this curve, okay. So for that curve, we can represent in this format. So here this angle is what? D theta. And radius is what? Radius is r. So finally, what will be the length of this arc? This will be the r d theta. Like this, we are able to find this is r d theta, this is the r sine theta, okay? And differential length on the radius we are going to take. So that differential length is taken as the dr here. So now, finally, we can write differential displacement here. So that is very important for all coordinate system. What is the value of differential displacement? So that we are writing as the dl. So finally, if you are seeing that what we have dr, unit vector is ar. Then we have r d theta. What is the unit vector here? A theta. Next we have r sine theta d phi. What is the unit vector here? A phi. Like this, we are able to write the differential displacement. Next, we'll see what will be the expression for the differential area. So for the differential area, we are considering as the ds. So again, if you see that here, three different surface we are going to get. So now if you'll see outside, we have r d theta, r sine theta, and finally that vector will be the radially outwards. So finally, this ds in this situation we can write as r d theta into r sine theta d phi, and vector is what? AR. So finally, if you see rearrangement of this, we have r square sine theta d theta d phi and radially outwards. Okay. So now if you see the another surface. So this is the one what we have seen outside. This is the another surface. Suppose this part you are going to write here. So this is the dr. Okay. Then we have r sine theta. So that will be written as here another part. So dr, okay, dr, and we have r sine theta d phi. So this is along the direction is what? A theta. So again, you can rearrange. So third one is finally uh, another part. Okay, backside of this. So that one is the r dr d theta. Dr is there, r d theta we have rearranged. So finally, vector is what here? Unit vector is the a phi. So finally, what is left here? Differential volume. What will be the differential volume here in case of spherical coordinates? So for the differential volume, we are going to multiply all these three length what we got here. So that length is what? dr r d theta, and we have r sine theta d phi. So finally, if you rearrange this one, what we have? R square sine theta dr d theta and d phi. Okay. So this differential length, volume, all these things, if you want to experience here, suppose for example, one we can show here, so you can understand in the better way. So this path, this one is what length? This is the RD theta. And this arc length is what? R sine theta d phi. So finally, this area vector will be what? Radially outwards AR. Like this, we can realize all other surface also here. Okay. So here we have parameters r, theta, phi, and they have a range. Okay. Theta is going to change from the 0 to pi. Phi is going to change from 0 to 2 pi. R is going to change from 0 to infinity. Okay. Thank you.